Today we will begin section 4.6. The first thing I'd like you to look at is journal page 103. You can see the fundamental theorem of algebra here. We have a theorem and a corollary for you to look at. In short, the corollary says that whatever the degree of the polynomial is, that tells you how many solutions you will have. If a solution is repeated twice, that counts as 2 solutions. You could also have imaginary numbers. And both imaginary numbers all the imaginary numbers come in pairs. Keep that in mind. Now let's turn to our notes. In our notes you can see a table here of some sample equations or polynomials. In the first one, the equation has a degree of 1, so this would be called linear. So notice a degree of 1, which is called linear, has 1 solution. The next one, we have an x squared, so we would call this a quadratic, right? And any quadratic will then have 2 solutions. You can see we have radical 2 and negative radical 2. The third one, we have a cubic. All cubics will have 3 solutions. In this example, we have 2, and we have negative 1 plus I radical 3 and negative 1 minus I radical 3. And in the last example, we have another cubic, but notice we have 3 real solutions. So let's just figure out how many solutions we will have. In example 1a, the question is how many solutions will this polynomial have? Well, all you're going to do is look for the highest degree. The degree is 3, therefore it will have 3 solutions. Looking at part B, how many zeros will that function have? And again, the highest degree is 4, so it will have 4 solutions. Now let's look at a graph. You can see that the graph has a curvy shape just like a cubic. So if it's a cubic, I know I'm going to have 3 solutions. Now let's figure out what types of solutions I'm going to have. I can see that I crossed through 1 time here, so that'll be 1 solution. Here, I don't actually cross through, I turn around, so that means there's actually going to be a repeated solution here. So there'll be 2 solutions there. When you touch and turn, it's repeated. So we have a total of 3 real solutions. Now I'd like you to try the monitoring progress 1 to 3. In the first 2, you're just looking for the highest degree. And 3a and b, both of them will be cubic. So how many real solutions will you have? How many imaginary? Just remember that the imaginary solutions come in pairs. So you'll either have 0, 2, 4, 6, etc. Now let's move to example 2. Now that we know how many solutions we have, let's try and find them. Now example 2 is just like we did in section 4.5, except now we could have real solutions and imaginary. Before we were working with all real solutions. Now let's figure out all the real and all the imaginary. We are looking for a total of 5 solutions, which is a lot. So let's try one. So I can't factor this, it's a big polynomial. So what I'm going to do is do synthetic division with all my possible zeros. It starts out with a 1, so I'm looking for just factors of 8. So I want to either choose plus or minus 1, 2, 4, or 8. So I'm going to do synthetic division with 1. Notice I'm missing the 4th degree, so I need to put a 0 in. Then a 1, then a negative 2, negative 12, and negative 8. So I'm going to choose one of the possible solutions. Let's say I choose 2. And I'm going to complete synthetic division, and hopefully I'll get a 0. Notice I've completed synthetic division, and I do end in a 0. So x equals 2 will be one of my solutions. When I go to write my answer and put my x's in, notice I have a polynomial that's still quite big. In fact, I do not know how to factor this, so I actually have to do synthetic division again. Now you can use the same numbers that you finished with. I'm going to use the 1, the 2, the 5, the 8, and the 4. And I'm going to choose another possible number. I kind of already know the answer, so I'm going to give you a hint that we're going to try -1. Carry down the 1 and complete your synthetic division. It's -1, 4, and I will get 0 again. So x equals -1 will be a solution. I got 2 of them. I need 3 more. I'm going to write my answer with the x's. Now, this wasn't x to the 4th. I'm going to write it as x cubed plus x squared plus 4x plus 4. This is a polynomial with 4 terms, so hopefully I can do factor by grouping. So as you see here, I grouped up my 2 terms, took out an x squared from the first group and a plus 4 from the second group. So factoring by grouping, I get x plus 4 and then x squared plus 4. Each of these factors I'm now going to equal to 0 to find my other solutions. So when I do x plus 1 equals 0, I just subtract 1 and I get another -1 as a solution. So now I have 2, -1, and another -1. Solving this equation here, I'm going to subtract 4 over square root, and the square root gives me a positive or a negative, and the square root of -4 is 2i. So my other solutions are plus 2i and minus 2i. So my 5 solutions, I'm going to repeat, are 2. I have -1, -1, 2i, and -2i. So there's my 5 real solutions. I'd like you to just practice one of these. Let's try this one right here. Okay, you can't do factor by grouping, so you're going to need to do synthetic division. Use factors of 12 to try out. Hopefully you get a 0, and then try and factor what is left over and see how you do.